Bismillahirrahmanirrahim. Good evening, everyone. Today we will try to calculate the current at the non-ideal shortky, or by using another word, we will work to try to prove I equal or approximately the diode current. We will work on the shunt, or we can say parallel resistance. At forward bias and reverse bias. We will start from forward bias. From this circuit, we have the parallel resistance, RP or RSH. Here the voltmeter will calculate the voltage drop at the diode. And here the series resistance, here sensitive ammeter to calculate the current. We will start from Kirchhoff current law. Here the situation is different. I started from Kirchhoff current law, not like the others. We was starting from Kirchhoff voltage law. Kirchhoff current law equal, that's mean I input equal I output, that's mean I source, IS equal I diode plus the I at the parallel resistance or shunt resistance. We calculated ID equals saturation I naught exponential diode constant V minus 1. That's mean Shotky equation. And from Ohm's law, ISH from Ohm's law equal VD, the voltage, the diode voltage divided on parallel resistance. We put all of these equation 2 and 3 in 1 and see. Now we must calculate VD to complete the equation. We can find the result of VD by using Kirchhoff voltage law. V total equal 1 plus 2 diode voltage plus series resistance voltage. That's mean VD equal VT minus VRS. VRS we know equal from Ohm law I naught RS. The current will be I naught exponential alpha V minus 1 plus V total minus I naught RS divided on RSH at non-ideal Shotky equation. From equation 1, I equal ID plus ISH parallel resistance and plus diode current. At forward bias, what will happen? ID will be bigger than the parallel current, resistance current. And we can ignore I parallel current because it's very small amount. That means I equal approximately equal diode current. Now let's talk about why ISH or current at parallel resistance equal near from 0, because like we know here the diode at forward bias. What does mean? That means the diode will let the current through from it, and here the resistance, the parallel resistance will be something like wall. Will try to prevent the current from through from it, because that I used another ring to explain that the current will approximately all the current will flow through from this circuit. How we can prove the non-ideal Shotky equation is correct? That's easy. Just we will dealing. That means when we dealing with ideal Shotky, that's mean when we dealing with ideal diode, that's mean RSH will equal 0, and we will put infinity ohm at our parallel resistance. Like I said before, no current or just very small amount current will through from the parallel resistance. That means it has a huge number. Let's use the same equation. I equals saturation current exponential alpha V minus I instead RS, I put it 0 plus V minus I0 divided on RS, put it infinity, and the equation will be like that. We come back again to shortcut equation I equal I naught exponential alpha V minus 1. That's it. Now let's work on reverse bias. Here, reverse bias, that means the diode will be like that. The minus terminal with positively terminal, and something like that from another side. That's mean what? That's mean here the diode will prevent to let the current through from it, and most of the current will through from the parallel resistance or shunt resistance. Most of the current will through from the RSH, the current at the shunt or the parallel resistance will be bigger than the diode current from Kirchhoff law. ID plus ISH, I equal ISH, because ID will be approximately 0 or equal very small amount, because that we can ignore it. Here RSH control on the I leakage. At reverse, I equal I naught exponential alpha V minus 1. That's the normal equation, the normal formula, but here we will put minus V instead V because we're dealing with reverse bias. I equal I naught exponential minus alpha V minus 1. We will put this result 1 divided on exponential alpha V, and that's mean very big amount, because here V is a huge amount. When I calculate the side will equal a very small amount, we can ignore it because that I equal minus I naught at reverse bias will be like that. The saturation current here V1, after that the curve will start to increasing. At reverse bias, the Ohm's behavior will dominate it, and I naught exponential alpha V minus I naught RS minus 1, we can ignore it to be I equal V on V minus I RS divided on the parallel resistance. Here, another note, semilog plot will be like that at forward bias, and we don't deal anymore with Ohm's law. At reverse bias, here the curvature behavior, here Lin saturation current, the relation between Lin high on y-axis and voltage at x-axis. Our lecture is done. Thank you so much about your listening, your patience. Have a good day. Pass.